Hi everyone. Today I'd like to talk to you about defining motion in physics. And by that I mean let's talk about position and what it means to be in motion. What it means to have a distance or a displacement, to have a speed or velocity, and what acceleration is. So to start with, we'll focus on understanding the difference between position, distance, and displacement, and then we'll understand the difference between speed and velocity. We'll look at solving a couple problems using average speed and velocity, and then we'll tie it all together as we calculate distance, displacement, speed, velocity, and acceleration. So, position. An object's position in one dimension we can assign to a position on a number scale. We can set the zero wherever we want, we can set whichever direction we want to be positive, as long as we're consistent within that problem. So if I set my current position where I am right now, and I call that 0, and I call out in front of me the forward direction, if my dog was 2 meters in front of me, my dog's position would be at 2 meters. I would say my dog's position x is equal to 2 meters. When position changes, an object travels some distance. How far you've gone is your distance traveled. The more position changes, the more distance is traveled, of course. Distance is a scalar, and its standard unit of measurement is the meter. So a sample problem, if we have a deer that walks 1,300 meters east to a creek for a drink, then walks 500 meters west to the berry patch for dinner, and then gets scared and runs 300 meters west when it's scared by a raccoon, what total distance did the deer travel? Well, the deer traveled a distance of 2,100 meters, or 2.1 kilometers. 1,300 meters plus 500 meters plus 300 meters. And that's a scalar. It doesn't need a direction. It has magnitude only. Displacement, on the other hand, is a vector which describes the straight line from where you start to where you finish. In some ways, it's sometimes called the position vector. It points you from your origin to that final point. Displacement, which we often call x minus x0, where x is your final position, x0 is your initial position, can be measured in meters. And sometimes you'll even see that written as the position vector as an S with a little line over it showing you that it's a vector, or sometimes even R with a line over it showing it's a vector. So it has several different symbologies, and it really depends on exactly what course you're taking and what book you're trying to get along with. In any case, if we have a problem of a deer walking 1,300 meters east to a creek for a drink, once again, our deer is going to go in a different direction. It's going to go 500 meters west then to a berry patch for dinner before deciding that he's going to go 300 meters west when scared by a raccoon. What is the total displacement for the deer? Well, to find that out, we go from our starting point, our origin, to our ending point and draw a straight line from start to finish. That red arrow is our displacement vector. The length or magnitude of that displacement vector, if we went 1,300 meters east, then 500 west, then 300 meters west, must be a total of 500 meters. So our displacement vector must be 500 meters east. Now, sometimes it's also important to know how long it takes you to travel a distance. We call that the average speed. That's the rate at which distance is traveled, and it's a scalar. And typically, we denote that V for speed. Don't ask me why. V stands for speed, and the line over it means that it's an average speed. And that's equal to the distance traveled. So when we have x written there, that's really the distance traveled divided by some amount of time. It's a scalar, and it's measured in units of meters per second. The way I remember speed is a scalar, s and s. If we look at this in a problem, our deer walked 1,300 meters east to a creek for a drink. Then he walked 500 meters west, then 300 meters west. What is his average speed if the entire trip took 600 seconds? Well, average speed was the total distance traveled, which we said was 2,100 meters, in a time of 600 seconds. So So the average speed was 3.5 meters per second. And since average speed is a vector, we don't need, is a scalar, average speed is a scalar, we don't need to include a direction. It's a magnitude only. Average velocity, on the other hand, does have a direction. It is a vector, and it's the rate at which displacement changes. So we said displacement we could write as x minus x initial, your final position minus your initial position, or we can also call that delta x. So average velocity, which is oftentimes shown with the exact same symbol, v for velocity with a line over it, so v can stand for speed or velocity, is delta x over t, the rate of change of your position or your displacement with respect to time. It's also measured in units of meters per second, and you can remember it's a vector. V velocity is a v vector. So, same problem again. Now our deer walks 1,300 meters east, then 500 west, then 300 west. What's the deer's average velocity if the entire trip took 600 seconds? Well, average velocity was our change in position, or our displacement over time, which we said was 500 meters east over 600 seconds, or 0.833 meters per second. And since it's a vector, we have to give it a direction. East. 0.833 meters per second east. Let's see if we can't put this all together as we talk about a problem involving our friend Chuck the hungry squirrel. Chuck travels 4 meters east and then 3 meters north in a quest to find a lovely little acorn. As he's on that quest, we want to know his distance traveled. Well, distance traveled is pretty straightforward. If he went 4 east and 3 north, he must have traveled a total distance of 7 meters. What's his displacement? Well, displacement then is the straight line distance from where you start to where you stop. That looks like a 3-4-5 triangle. Or if you didn't remember the 3-4-5 rule, you could use the Pythagorean theorem to find out that the length of the hypotenuse is 5 meters. So Chuck's displacement, x minus x naught, which is a vector, displacement, must be 5 meters northeast. Chuck's average speed is distance traveled divided by time, or 7 meters in 20 seconds is 0.35 meters per second. And if we want Chuck's average velocity is the rate of change of displacement, the total displacement or position change divided by time. Well, that was 5 meters in 20 seconds, or 0.25 meters per second. And since velocity is a vector, it again needs a direction, northeast. So 0.25 meters per second northeast is Chuck's average velocity. Some very subtle differences in these different quantities in physics. And the symbology changes quite a bit depending on which book you're reading, so I'm not going to get too hung up on it for now. As long as you understand the concept, the specifics, sometimes the symbols for these change from course to course. Finally, acceleration is the rate at which velocity changes, and acceleration also is a vector. It's your change in velocity divided by time, so that could also be written as v minus v naught over t. It's a vector, and its units are meters per second, or meters per second squared. That sounds a little funky, meters per second squared, but it really is saying if you have an acceleration of 5 meters per second squared, that's 5 meters per second per second. It means your velocity is changing 5 meters per second every second. Let's look at one last problem. If Monty the monkey accelerates, it's a smiley monkey, Monty the monkey accelerates from rest to a velocity of 9 meters per second in a time span of 3 seconds. Calculate Monty's acceleration. Well, acceleration is delta v over t. Delta anything is its final value minus its initial value divided by the time. The final velocity was 9 meters per second. The initial velocity, it said he was at rest, so that's 0, in a time of 3 seconds. 9 minus 0 is 9. 9 divided by 3 is 3. That will leave us with an acceleration of 3 meters per second, or 3 meters per second squared. And acceleration is a vector, so technically we do need a direction with this. However, it's fairly obvious from the problem that we're talking about the forward direction. So in this case, it's probably okay to not write the direction down. But really, if we wanted to be technically correct, we should have a direction with this as well. So next steps, take a few minutes, try and sort these concepts out, and see if you can explain in your own words the difference between position and distance, between distance and displacement, between speed and velocity, and finally between velocity and acceleration. If you can explain the way that you understand it, the difference between those terms, you'll be in pretty good shape. Of course, if you need more information or have questions, check out aplusphysics.com.